There are situations different organizations or different bodies of an organization requires to roll out machine learning models to edge points, possibly anonymous edge points through Brazilian networks. For example, organizations collaborate to deploy autonomous devices into places, say, mines or space, and decide to improve the system through rolling updates. This scenario requires a mutual agreement on who is authorized to roll out updates, what criterion should be met with model performance metrics, but doesn't care the time it takes to update the entire decentralized network of deployed system. Nodes eventually updates themselves and shares it with others in the network. Another use case is in disaster management by government bodies. Authorized bodies are able to connect with the people even through token networks. My name is Jubin Jose, and I am presenting a working prototype of aforementioned solution. Immutable ledger of improved models, identifiable participants in permission network, low latency, privacy and confidentiality, persistent availability of ML models, permanent addressing, offline first content distribution are the features of proposed solution. Organizations train new models and test them against a common test data. If the resulting metric meets the validation criteria, it will be recorded in a blockchain along with the cryptographically unique content ID for the generated model. Then, this model ID is distributed from a peer-to-peer network through PubSub notification. An edge node receiving this notification will address the content and retrieve it through the same peer-to-peer network. I use Hyperledger Fabric to implement permission blockchain and IPFS for model distribution. Please don't forget to clone the prototype repository, link in the description. In this demo, I am going to build a fasttext model for a chatbot. Let's start the Fabric network. Our chain code is written in JavaScript. Then start our application to interact with the chain code. Now we are going to train the fasttext model, add a new model to IPFS network, and commit IPFS ID into blockchain along with its validation metrics. Then we start PubSub broadcast global state from the Fabric blockchain. On client side, we run an IPFS daemon to listen to the update notifications. Once a new update is available, that updated model will be downloaded. Here I use that model to make predictions for my chatbot. Now I'm switching to server. Now let's see what happens when the organization performs another training, commit, broadcast actions. New update is available immediately in the client, and the chatbot uses new model to make predictions. Thanks.